Hello students, I am Sasitrakar. Welcome to Cars Physics. This is my lecture 1 on the subject electric charge and electric field, which comes under the units electrostatics. Okay. Before starting the discussion, let's have an idea about electromagnetism. Electromagnetism is divided into two units, electrostatics and electrodynamics. Electrostatics. Okay. Electrostatics is the branch of physics which deals with the electrical properties of charge when it's at rest. Okay. Similarly, electrodynamics. Dynamics means motion. Okay. Electrodynamics is the branch of physics which deals with the electrical and magnetic properties of charge when it's in motion. Okay. And you know, when a charge sets in motion in a conductor in a given direction, then the conductor constitutes current, and a current carrying conductor produces magnetic field all around it. We'll discuss all these things. Okay. Then under electrostatics, the units electrostatics under which there are four subjects: electric charge and electric field, Gauss law, electric potential, and finally capacitance. Under electrodynamics, electric current, direct current we will study first, then magnetism, then magnetic effects of electric current, and then electromagnetic induction EMI. Number 5, alternating current AC, DC and AC, direct current and alternating current. Then finally electromagnetic waves. Okay. So these are the basic fundamentals. Then electromagnetism. See students, first we start from electrostatics again electrodynamics again electro. Let's discuss about electro. Okay. Before starting the subject, these are basic thoughts or basic discussions. Okay. Electro, we have defined charge at rest or charge in motion. Electro, the term comes from electricity. Okay. Electricity. Electricity is derived from a Greek word, electron. Electron. A Greek word, electron, which is ancient name of amber. Ancient name of amber is electron, from which electricity, the name is derived. Okay. Then discovery of electricity. We will discuss about discovery of electricity in very short time. Okay. The origin of electricity. Origin of electricity goes back to 600 BC. Okay. And discovery of electron is credited to Greek philosopher Thales of Miletus. Okay. Thales of Miletus. In 600 BC, Thales of Miletus observed that when amber is rubbed against fire, what is amber? Amber is a yellowish resinous substance, stone-like substance. Okay. Amber is a yellowish resinous substance usually found at the shore of Baltic Sea. Okay. He found that when amber is rubbed against fire, then amber acquires the property of attracting lighter objects like small pieces of straw, hairs, etc. Okay. It was a fact of astonishing that without contact, how after rubbing the amber it attracts lighter objects. So from first observation, it was clarified that this type of force is not a contact force. As we either push or pull a body, with physical contact. Okay, this type of force is not a contact force. Okay, so from first observation, it was appeared as force due to field. Okay, we'll discuss all these things. Then the experiments were carried out, and finally the observations were like this. This type of force is not only attracting but also repelling. How? You know, you have done some experiments. If you rub a plastic scale on hair, then after rubbing, the plastic scale acquires the property to attract small pieces of paper. Okay, we'll discuss the mechanism behind it in our discussion. Okay, also it is found that when a glass rod is rubbed with silk, then also glass rod attracts lighter objects. Okay, see, suppose these are two glass rods rubbed against silk, then both the glass rods acquire the property lighter objects like small pieces of paper. So this is force of attraction. But same two glass rods, when brought closer, then they start repelling each other. Okay, so from observations, it is found that this force, this type of forces, is not only attracting but also repelling. Also, it's found that suppose a glass rod is rubbed against silk, then it attracts small pieces of paper. If once the glass rod is brought in contact with the paper, then it loses the property of attracting. Okay, so the conclusion discussion: when a body rubbed against another body, means when two different bodies are rubbed against each other, then the bodies acquire the property to attract lighter objects. This is due to transfer of charge. Okay, then finally, if a body attracts another body and once it touched or brought in contact with the body, then it loses the property of attracting. Okay, so due to this, finally, Benjamin Franklin, on the basis of this logic, means if the bodies are once touched, then they lost the property of attracting. Means the charges in the bodies, when a body loses charge, it becomes charged. When another body gains charge, also it becomes charged. We'll discuss all these things. But when they are brought in contact, then their charges are neutralized. Okay. On the basis of this logic, sum of charges is zero. On the basis of this logic, Benjamin Franklin named the charges as positive and negative. Okay. So now our discussion on electric charge. See students, this is my lecture 1 on this subject. This is only introductory class, and in this class we will only discuss on electric charge. Let's start. Electric charge. Electric charge and electric field, and our discussion is electric charge. Okay. Electric charge. Let's define first. Electric charge is intrinsic property of matter. The definition is yet to be completed. Okay. Electric charge is intrinsic property of matter. What is intrinsic? Intrinsic means fundamental or basic property of matter. Mass is intrinsic property, means basic property. Okay. Similarly, charge is intrinsic property or fundamental property or basic property of matter. What is matter? Our definition is incomplete. Incompleted. We'll complete it in later stage. Up to this now. Matter. In simpler way, matter is that which composed of atoms and occupies some space in very simpler way. And you know the atomic structure. Let's discuss in a very short form. Atom. Atom consists of a massive core which is called as nucleus. Nucleus contains neutrons and protons. Okay. Neutrons are electrically neutral. Okay. Only the charged particles in nucleus are protons which are positively charged. Okay. Around nucleus, electrons revolve in different orbits. Okay. The electron which revolves around the nucleus in outermost orbit is valence electron. Okay. So, in a good conductor, insulator and semiconductor will describe all these things, but a good conductor is that which allows the flow of charges in it, and flow of charge due to free electrons. What are free electrons? Okay. This electron is now in outermost orbit revolving around the nucleus. Okay. If this electron gains some energy, then it will be made free, because the force of attraction, we will discuss, dissimilar charges attract each other. Nucleus is positive, electron is negative. We will discuss all these things, and you know also the fundamental. So, force of attraction on electron due to nucleus is very small, as it is sufficiently apparatus from the nucleus as compared to other electrons. Okay. Of course, its binding energy is also very small. You will know all these things, okay, in later stage. So, when electron or atom gains energy from external source, then it becomes energetic and is made free from the orbit. Okay, this is fundamental discussion. We will analyze all these things. So, electric charge is intrinsic property of matter. See, proton is positive, electron is negative. So, our definition is incomplete. We will complete this, but not now. Now it is incompleted. Okay. Then about charge. Then the conclusion after all researches. Okay. Number one, about charge. Number one, only two types of charges exist in nature. That is positive and negative. Only two types of charges exist in nature. Positive and negative. Only two types. Okay. Also it is found that similar charges, positive or negative, repel each other. And the dissimilar charges, either positive or negative attract each other. Okay. These are from experiments. Similar charges repel and dissimilar charges attract. Similar, positive, negative, repel each other, and positive, attract each other. Okay. Then about charge, some other points. Conventionally, the name of negative charge is electron. Okay, and name of positive charge is proton. Then magnitude of charge of electron, as it is observed, as it is found from experiment, magnitude of charge of electron is minus, electron is negative, 1.6 into 10 to the power minus 19 coulomb. Coulomb is units of charge in SI. We will discuss it. Then similarly, charge of proton is positive, magnitude is same, 1.6 into 10 to the power minus 19 coulomb. Then mass of electron Mass of electron is found to be 9.1 into 10 to the power minus 31 kg, and similarly mass of proton is found to be 1.672 into 10 to the power minus 27 kg. If we compare between mass of proton and mass of electron, then mass of proton is about 1837 times that of mass of electron. So proton is heavier as compared to electron, since its mass is much greater than mass of electron. Okay, so this is about electron and proton, the constituent particles of atom. Okay, next, unit system, units of charge. Units of charge. See students, you may take a screenshot or you may see it repeatedly. All these are very important discussion. Okay, units of charge, very fundamental and useful discussions, very fundamental and easier things also. In SI, charge is a derived quantity, that fundamental. In SI, charge is a derived quantity, and in SI the units is coulomb, written as C, 1 coulomb. 1 coulomb is equal to 1 ampere into second. As you know, current is rate of flow of charge, strength of current, rate of flow of charge. So charge is current into time. In SI, current is fundamental units, units of current is ampere, and time is fundamental, units of time is second. So in SI, charge is derived quantity, units of charge is coulomb, 1 coulomb is equal to 1 ampere into second. Then in CGS, ESU, units of charge is 1 ESU of charge, or we may write it 1 start coulomb. In CGS, EMU, we will establish a relationship between coulomb, start coulomb and EMU of charge. Okay, in CGS EMU, units of charge is 1 EMU of charge or 1 absolute coulomb. Absolute coulomb is written like this, absolute coulomb. Okay, then practical units, these are on the MKS and CGS, means SI and CGS practical units of charge. Number 1 ampere hour, and you know 1 hour is 3600 seconds, and 1 ampere hour is 3600 ampere second, and 1 ampere second is 1 coulomb, then it's equals to 3600 coulomb. 1 ampere hour is equal to 3600 coulomb. Then practical units is also 1 farad. 1 farad is 96500 coulomb. 1 farad is the largest units of charge, and 1 ESU is smallest units of charge. It to be remembered, 1 farad largest units of charge and 1 ESU is smallest units of charge. Okay, so these are about units of charge, different types of units. Okay, then we have to complete our definition, very important definition. I am completely writing the total form and you may take screenshot. Okay, charge is, electric charge is intrinsic property of matter due to which it produces and experiences both electric and magnetic effects. This is fundamental definition of charge. Charge is intrinsic property of matter. Okay, Matter contains atoms and fundamental particles of atoms are electrons and protons, means negative and positive. Okay. Neutron is uncharged. Okay. Intrinsic property of matter due to which it produces and experiences both electric and magnetic effect. Then question arises, as we have discussed, when a charge produces electrical effect and when it produces magnetic effect. Number one, a charge at rest, maybe a single charge or maybe a system of charges. A charge at rest produces only electric effect. Okay, electric effects. Then how can you be convinced? See, suppose this is a body having some mass. If the body is kept in space, then you know from gravitation this body will produce an imaginary space or region around it, which is called as gravitational field. Means it may attract other bodies within its field. Similarly, if you keep a charge either positive or negative, charge, symbol of charge is Q or Q. Okay. Charge is another property. Charge is a scalar quantity. Okay. Charge is scalar. Okay. If you keep a charge in space either positive or negative, then it will produce an imaginary space or region around it, which is called as electric field. If any of charge comes into the field, then it may attract or repel. If it is positive charge, then it will attract positive. It will repel positive and attract negative charges. If it is negative, then it will attract positive and repel negative. So this is electric field. So a charge at rest produces only electric effect. Okay. Then second point, charge in motion produces both electric and magnetic effect. As we have discussed, if a charge is in motion in a conductor, then the current carrying conductor produces magnetic field all around it. Also due to presence of charge, it produces electric effect. Thus a moving charge produces both electric and magnetic effect. Then under this moving charge, first point, a charge moving uniformly means charge is moving, produces both electric and magnetic effect. Moving charge produces electric and magnetic effect, but charge moving uniformly. Uniformly means charge moving with constant velocity or uniform velocity, means speed and direction both are constant. A charge moving uniformly doesn't radiate energy. So, a charge moving uniformly or charge moving with constant velocity produces both electric and magnetic effect but doesn't radiate energy. Very important to be remembered. Okay. Then number second part, B, a charge in accelerated motion. In accelerated motion, a charge in accelerated motion means it's also a moving charge. A charge in accelerated motion produces both electric and magnetic effect, and accelerated motion radiates energy. A charge in accelerated motion produces both electric and magnetic effect as well as radiates energy in the form of electromagnetic wave. Okay, this is definition of charge. Okay, from this definition, what do we have understood? A charge moving with uniform velocity or constant velocity produces both electric and magnetic effect but doesn't radiate energy. But an accelerated charge produces both electric and magnetic effect as well as radiates energy. Now, a question for you: a charge moves uniformly along a circular track on a circular track. Does it radiate energy? This is the question to you. I will discuss. Well, I will go to complete or end the lecture 1. Okay? Carry on thinking. You can answer. I think you have taken the screenshot. 1, 2, 3, 4. Okay. This is about charge. Then another discussion means fundamental discussion on electrification. This is your question. Electrification or charging. We will discuss the whole concepts of electrification and charging in lecture 2, different processes of electrification, and very important discussion. Okay, different processes of charging and various important discussions on the charging. In this class, only fundamental. Electrification or charging. Usually, a body is neutral because the body is composed of atoms. Atom is electrically neutral. Number of protons in an atom is equal to number of electrons in the atom, and we know charge of electron is equal to charge of proton. Total number of positive charges is equal to total number of negative charges, so resulting charge of atom is 0. For example, you know it. If we consider hydrogen atom, then it has 1 proton and 1 electron. If we consider sodium atom, then it has 11 protons and 11 electrons. So sum of charges is 0, since charge of electron is equal to charge of proton and one is negative, other is positive. Charge is scalar quantity, so algebraic sum of charge is 0. Okay. So usually a body is neutral because the body is composed of atom. Atom is electrically uncharged or neutral. So the body doesn't possess the property to attract lighter objects. Okay. But as we have discussed, if two different bodies, basically this type of electrification takes place in case of insulators, we will discuss in brief. If two bodies are rubbed against each other, then they acquire the property of attracting lighter objects. Okay. So how this happens? If a body is rubbed against another body, means two bodies have different types of material. Okay, different types of body, different types of substances and different types of materials. If a body is rubbed against another body, then due to friction on the surfaces, energy is lost, as you know. Okay, if a body is rubbed on the surface of another body, then due to friction, energy is lost. And the loss of energy appears in the form of heat. That thermal energy which is produced due to rubbing a body against the surface of another body, that thermal energy helps the outermost electron, means the electron which orbits around nucleus in outermost orbit. That thermal energy helps the outermost electrons to be detached from the orbit and to be transferred from one body to another body. Okay. Previously, suppose this body is neutral. After rubbing it, suppose a glass rod is rubbed against silk. If a glass rod is rubbed against silk, then it is found that glass rod becomes positively charged and silk becomes negatively charged. How it happens? Because the glass rod is neutral. When it is rubbed, then electrons are transferred from glass rod to silk. So previously the glass rod has equal number of electrons and protons. When it rubbed against silk, then it loses electron. So there is a deficit of electrons, deficit of negative charge. So resulting charge of the glass rod is positive. And silk gains electron. So resulting charge is negative. So if two bodies are rubbed against each other, then charge is transferred from one body to another body. The body which loses electron becomes positively charged, and the body which gains electron becomes negatively charged. We'll discuss it in lecture 2. In brief, this is the process of charging, and nature of charge develops in a body depends upon nature of material. Okay, this is about charging. We'll discuss it. Then today's discussion is only about charge. Now our discussion comes properties of electric charge. Very important discussion. Okay, I hope all these discussions will be very useful for you. Okay, for fundamental. Number 1. Quantization of charge. Quantization of charge. Okay, I am writing the definition completely. You should write. Okay. If a physical quantity, I will discuss if a physical quantity can have only discrete value rather than any other values, then the quantity, physical quantity, is said to be quantized. If a physical quantity can have only discrete value, what is meaning of discrete? Meaning of discrete is fixed or constant. If a physical quantity can have only discrete value rather than any other values, then the quantity is said to be quantized, and this is quantization of charge. So charge is available in a body in some fixed amount. Then how can you understand it? See, students, total charge available in a body like Q may be positive or may be negative. If a body loses electron, then it becomes positively charged. If a body gains electron, then it becomes negatively charged. Okay, let a body has either positive or negative charge, the magnitude of charge is Q. Okay, then according to the quantum nature of charge, or as we have written, quantization of charge, total charge available in a body is integral multiple of charge of the electron. Means value of n is for a charged body, value of n is 1, 2, 3, 4, 5, etc. Means the value of n must be a complete integer. Means n can never be a fraction of fraction. N can never be a fraction, means value of n can never be less than 1. This is in accordance with quantum nature of charge. Okay, so minimum value of n charge, minimum value of n is 1. So here I am writing minimum charge for free existence is 1 quantum of charge. Minimum value or minimum charge for free existence or for independent existence is 1 quantum of charge. That's equals to, if n is 1, then charge of 1 electron. Okay, so minimum charge for free existence is called as 1 quantum of charge. That's equals to charge of 1 electron. If a body loses 1 electron, then its charge is plus 1 e. If a body gains electron, then its charge is minus 1 e. So minimum value of charge is charge of 1 electron. This is called as quantum, 1 quantum of charge. This is in accordance with the law of nature. Okay, this is in accordance with law of nature. It means less than 1 electronic charge never exists freely or independently. Means a body can't have a charge which is less than 1 electronic charge. Okay, this is about quantum nature of charge. Again, another question. Under this, I am writing. This is first property, quantization of charge. Question number 1. Then question number 2. A body has a charge 16 into 10 to the power minus 18 coulomb. Let it is positive. How many electrons are lost by the body? Very simple question. Okay. A body has a charge of plus positive charge 16 into 10 to the power minus 18 coulomb. Then if the body is positively charged, then it has lost some electrons, means electrons are transferred from the body. Then how many electrons are left by the body? Okay. Then this is our discussion, minimum amount of charge for independent existence or for free existence. A charge of 1 electron, a body can't contain less than 1 electronic charge in accordance with quantization of charge. Okay. Then experiment shows that less than 1 electronic charge also exists, but not free. Less than 1 electronic charge exists, but not free. Okay. For example, charge of proton. Proton is positive. Charge of proton is, see, less than 1 electronic charge. Less than 1 electronic charge means fractional charges are called as quarks. Means 2/3 of charge of electron, 1/3 of charge of electron, etc. Means less than 1 electronic charges exists, but not free. Charge of proton is equal to charge of electron, but proton is positive. So charge of proton contains 2 of quarks. 2/3 of charge of electron is of positive. 2/3 of charge of electron plus 2/3 of charge of electron. Charge of proton contains 2 up quarks and 1 down quark, means down quark is minus 1/3 e. So this is equals to charge of 1 electron, positive. Okay. Similarly, neutron. Neutron is electrically neutral. Neutron contains 2 down quarks, sum of 2 down quarks minus 1/3 e, and 1 up quarks, means 2/3 of charge of electron. So resulting charge of neutron is 0. Okay. This is about quantization of charge. Okay. Next discussion, property number 2. Second property of charge. Second property of charge in accordance with quantization of charge. Charge has additive nature. Charge has additive nature. See, we have discussed, according to quantum nature of charge, total charge available in a body is sum of charge of electrons. Means charge is equal to N. Charge is scalar quantity. So total charge is algebraic sum of charge of electrons. So this is also shows additive nature of charge. Means total charge available in a body is algebraic sum of charge of electrons. Okay. Next property, number 3. Conservation of charge. Very important. Conservation of charge. Charge is conserved, means charge obeys this law of conservation of charge. It is very simple. According to law of conservation of charge, as you know, conservation of energy, conservation of angular momentum, okay? According to law of conservation of charge, charge can neither be created nor be destroyed, but can be transferred from one body to another body. And total charge of this whole universe always remains constant or conserved. Charge is conserved. Okay. This is about law of conservation of charge, but we need some extra points. Okay. Under conservation of charge, first point, total charge of an isolated system is conserved. Conserved means constant. It's conserved. Total charge of an isolated system is conserved. Let's discuss it. Suppose this is a box, insulated box, means though the box is placed on a surface, but it is totally insulated. Means there is no conducting surface, inner or outer. Okay. Total box. We may imagine this box is insulating box. Okay. Suppose there are 4 charges are kept in it. These are also insulating partitions. Let this charge is a body contains a charge of plus 2 coulomb. This is another body contains a charge of plus 16 coulomb. This is a body. This contains a charge of minus 5 coulomb. And this is a body contains a charge like plus 1 coulomb. So these bodies are not in physical contact with each other. All these bodies may be assumed to be conducting body, means metals. Okay. Now remove the partition walls. Then these charges will come in contact, come in physical contact. Okay. Or you may make the box up and down once or twice. Then finally the charge will be distributed among the bodies. This is first body. Let first body becomes plus 5 coulomb. Second body becomes plus 9 coulomb. Third body becomes plus 2 coulomb. Okay. Then fourth body has a charge Q. We have to find Q. Okay. Charge is conserved. Means now electrification takes place. When the bodies come into physical contact, the conducting bodies, will study it under conduction in next lecture. So charge will be distributed among the bodies, but total charge remains constant according to law of conservation of charge. So total charge before they are brought in contact, 2 coulomb plus 15 coulomb plus 1 coulomb minus 5 coulomb. This must be equals to total charge 5 coulomb plus 9 coulomb plus 2 coulomb plus K. So this is 2 plus 16, 18 plus 1, 19 minus 5 means 14 coulomb. This is 9 plus 5, 14 plus 2, 16 coulomb plus K. Okay. Then Q. Q is equal to 14 coulomb minus 16 coulomb means it is equals to minus 2 coulomb. Okay, charge is conserved. So now after they are brought in contact, charge remains same, and we found the unknown charge Q is minus 2 coulomb. So this is point 1. Total charge of an isolated system is conserved. Okay. Then number 2. Second point. During, very important discussions, during the processes of electrification, charge is conserved. We have also discussed this point under this first point A. Let's again discuss. Suppose this is a glass rod rubbed against silk. Okay. before they are wrapped in glass rod, let's consider lead. There are 1000 number of electrons and 1000 number of protons, and in silk, this is glass, this is silk. In silk, lead, there are 500 number of electrons and 500 number of protons. Then they are wrapped. When glass rod is wrapped against silk, glass rod becomes positively charged. Then electrons are transferred from glass rod to silk, lead. 200 electrons are transferred from glass rod to silk. Then thereafter, total charge of glass rod becomes 200 electrons are transferred to silk, means here now 800 number of electrons and 1000 number of protons. So glass rod becomes positive because there is deficit of electrons. Okay, resulting charge is positive. And in silk, total number of electrons becomes 700, 500 plus 200, and again total number of protons is 500. Okay, so before the glass rod wrapped with silk, total charge of glass and silk, total number of electrons is 1500 and total number of protons is 1500. Then after they became charged, total number of electrons 800 plus 700, 1500, and total number of protons 1500 is also 1500. So charge is conserved during the process of electrification. Third point, very important, conservation of charge holds good in any type of reactions. Any type of reaction may be chemical or nuclear or decay. Conservation of charge holds good in any type of reaction, chemical or nuclear or decay. Conservation of charge, law of conservation of charge holds good. Under these second 2 points I am writing, I am erasing the second point. Okay, very important. During annihilation and pair production, charge is conserved. That is difficult to understand this part. Okay, it will be studied in chemistry, very easy. Annihilation and pair production will be studied in chemistry, and again you will learn there that charge is conserved. This is about conservation of charge. Then final point, charge is associated always. Charge is always associated with mass. Okay, means charge is always associated with mass. It means charge can't reside without mass. So charge always comes with mass. What we have discussed, the minimum amount of charge for free existence is charge of electron. Electron has mass. So charge is always associated with mass. Charge always comes with mass. Means without mass, charge can't reside. Okay. And compare between charge and mass, and it will be very important for a charge and mass. Charge is intrinsic property. Also, mass is intrinsic property of matter. Charge is intrinsic property of matter. Mass is also intrinsic property of matter. Charge is scalar. Mass is also scalar. Okay. Charge. Charge has quantum nature. Charge has quantum nature. Also, mass has quantum nature. Okay. But one quantum of charge, is equal to charge of one electron, but one quantum of mass I don't know. One quantum of charge means minimum amount of charge for free existence is charge of electron, but one quantum of mass I don't know, because one quantum of mass is yet to be found. It's not found till now. Okay. Then charge can't reside without mass, as we have discussed, but mass can reside without charge. Where there is charge, there must be mass, because charge comes with mass. Charge can't reside without mass, but mass can reside without charge. See, this is a neutral body. It has mass, but resulting charge of this body is zero, because the body is composed of atoms. Net charge of atom is zero, so net charge of the body is zero. This body has zero resulting charge, but mass of the body is, let n 2 kg, 5 kg, whatever you may say. So mass can reside without charge. Okay. Charge is independent of velocity. Suppose a body has some charge, positive or negative. This body is at rest. If the body is set in motion, means moves with some velocity and velocity increases or decreases, then charge of this body remains same or constant, means charge is independent of velocity, but mass depends upon velocity. As you know the relationship, moving mass is m, rest mass is m naught, then moving mass is given as m naught upon square root of 1 minus v square by c square. Rest mass of a body is m naught. Suppose the body is moving with a velocity v. See students, suppose this is a body has mass 2 kg. This body is moving with a velocity 10 meter per second, 100 meter per second, 1000 meter per second, then mass will not change, because velocity of light is 3 into 10 to the power 8 meter per second. Even if a body moves with a velocity of 1000 meter per second, then v is much less than c. Okay, so v is negligible as compared to c. So v square by c square may be taken as 0. So m is equal to m naught, means mass will not change. But if a body moves with a velocity v, which is comparable to velocity of light, but nobody can move with velocity of light, so v is comparable with velocity of light, means nearly same. Say a charged particle moves with a velocity 3 into 10 to the power 6 meter per second, which is nearer to 3 into 10 to the power 8 meter per second. Then v is less than c, so ratio of v square to c square will be less than 1. Suppose v square by c square comes to be less than 1, then m will be greater than m0, means when a body of mass m naught, rest mass m naught, moves with very high velocity, and if that velocity is comparable to velocity of light, then its mass increases. Okay, this is about comparison between charge and mass. In final step of this lecture, okay, we'll discuss the two questions. I think you have already solved it. Okay, answer question number 1. A charge moves uniformly on a circular track. Okay, a charge moves uniformly. You know, uniform circular motion. If a charge moves uniformly, means charge moves with a constant speed on a circular track. Okay. Again, you know, if a body moves on a curved track, then velocity at every instant, at every point changes due to change in direction. Speed is constant, means magnitude of velocity is speed, magnitude of velocity is constant, but velocity changes. If the particle or the body moves in anti-clockwise order, then at any point, suppose at this point, this is direction of velocity, let it be v1, let this velocity is v1. Okay. At this point, this is direction of velocity, let this velocity is v2. At this point, this is velocity v3. So at every point, there will be tangents in different directions. So velocity has different directions at different points. Here, v1 not equals to v2, not equals to v3, and so on. But magnitude of v1 is equal to magnitude of v2 is equal to magnitude of v3 is equal to speed. Okay. Thus, when a charge moves uniformly on a circular track, its speed remains constant, but velocity changes due to change in direction. Due to change in direction of velocity, the acceleration is produced. You know it. It's called as centripetal acceleration. Though the charge moves uniformly on a circular track, but it is in accelerated motion. Speed is constant, but motion is accelerated. Thus, yes, it radiates energy. Our answer is yes, because it is in accelerated motion due to change in direction of velocity. Okay. Then question number 2. Very easy. Total charge of a body is 16 into 10 to the power minus 18 coulomb. Q is equal to M is equal to 16 into 10 to the power minus 18 coulomb. The body has a positive charge, so electrons are transferred from the body. Number of electrons transferred M, 16 into 10 to the power minus 18 divided by charge of electron, 1.6 into 10 to the power minus 19, and you will get 100. Okay. So this is the end of lecture 1. See students, in lecture 2 we will discuss different processes of electrification, friction, conduction and induction, and again I will assure you, we will discuss all the concepts of charging. There are different important questions and different important points under the processes. Okay, we will discuss the complete concept. Okay, thank you for your support. Thank you again. Be prepared.